So tell me, just turn your mic on if you had something else you'd like me to do. Okay, let me know. Okay, so what I'd like to do is go over the ones I didn't go over in extra help. Let's see if I can find those. You can hear me, girls? Catherine, can you hear me? Could you just turn on your mic just so I know you can hear me?
Yeah, we can hear you.
Good, good. Like I said, anybody want to shout out and let me know that you came on to talk about something in particular, or would you rather me just sort of take over and do some problems? Okay. Or is there a particular thing a lot of people focused on the friction, but there actually isn't very much friction. I would imagine it's three questions. Like I said, I think two to three are super easy. Let's go over. I wonder if we did gravity and momentum. Let's take a look at this. Uh, well, there's only three, and let me see if there's anything worthwhile. It's not. Nah, 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 nah. That's not good. Let's see. We did friction one and two. Let's see. Did we do weight? Yeah, let's do weight because we didn't do it in the extra help. All right, girls. So on the surface of a planet, this is M. This is weight because it's newtons. This looks like a question I think is on the test. So let me get what if I can get my pen out here? Give me a second. See if I can do this. Hold on. I don't even know. Let's see. Yeah, that's good. Oh, good. Can you see that? Someone turn on your mic and just let me know if you can see. Can you see that writing? Oops.
Yeah, we can.
Great, great. Let me see. Hold on. Okay. So what do you do on the test? M. Uh, Now why is that weight? Because it says weighs. FG. What is the acceleration due to gravity, girls? That is G. So I go to my reference table, and you know what I see? I find something that fits, and I'm pretty sure there's a question. I think there's a question both on the midterm and on this next test. So this is a good one. What is the acceleration due to gravity? G equals Fg newtons. 20 newtons divided by m, 5 kilograms, and that turns out to be 4. Good. There you go. Okay. Any follow-up questions, girls? I wonder how I get this thing off. Hold on. I'd like to get this off the screen, but I don't know how to do it. I'm going to have to just tap this again and then go to, uh-oh, yipes. That'll be close. Okay, good. All right, an apple. I've talked to you about this. Think of Newton's apple. Apple weighs a Newton. That's easy to remember. I don't think I have anything on the test like that, but you might see it on the midterm, maybe as 10 to the 0, which also is 1. Good. Another good question. A planet gamma m is kilograms. Gravitational force is F sub g. And so we do it again. We go to the reference table. Give me a second here and go G. What is it going to look like? That's what's going to look like on the reference table. What's the acceleration due to gravity? That's this. Look how easy this is. 24 newtons divided by 4 kilograms, and pretty easy, right? Acceleration due to gravity. Any follow-ups on that, girls? So pretty sure I typically put one of those on there, okay? Let's try it again. What's the fundamental unit to express weight? Well, that's newtons. Which one of these is newtons? Watch how easy this is. I know that F equals ma, kilogram, times meters per second squared, right? M times A is F. So right there, kilogram times meters per second squared. Tell me if I'm going too fast or you want to follow up. Just turn on your mic. Um, Bathroom person. This is like one of the old. I think this is actually not even doesn't even belong on this unit. This is the previous test about the elevator to bathroom scale. You remember that, so we'll skip it. Here's another acceleration due to gravity. What is that? That's little g. On a planet X is there's my little g. Oh, good. This is a different question. The person weighs. What's that? F sub g. What is the mass? Once again, what fits all that stuff? Because, all right, what is the mass of the object? That's m. So G is 19.6 meters per second squared. What's the force of gravity? That's 980 because that's the newtons. Force of gravity over m. So cross multiply. 19.6 m equals 980. I think, what does that turn out to be? How do I have to divide both? So I don't have a calculator. Maybe somebody could do that for me. That's about that's 19. It's about like 1,000 divided by 20. So that's like 50. Tell me if I'm wrong. Anybody got a calculator? I think it's 50. If I'm wrong, shout it out. All right. But I think if you do 980 divided by 19.6, so that's pretty easy. An apple weighing 1 Newton is what mass? So this is interesting. An apple weighs 1 Newton, Fg. Where does it weigh on the Earth? G is 9.8 meters per second squared. What is the mass? Once again, so you're really going to do well on these problems because we did a ton of them already. So it's 9.8 meters per second squared. What is the weight of 1 Newton? M. And so I think that's about right there, point one. We could do the math because you got to do 9.8 m cross multiply like in math class, divides both sides by 9.8, get about point one. Any follow-up questions or things you're confused about, just turn on your mic. Okay, good. Um, nice question. I may have put this on a test. Who knows? Let's see. Satellite accelerates away from the Earth. What happens to the mass? Well, it just remains the same. What does go down is the weight or the pull. That's going to go down the further away you go, till you're weightless, right? You're so far away, you're weightless. Okay. All righty. And my recording, I think yeah, good. Just double checking. What's the most, I'm not going to ask a question like this, most likely mass of a high school student. I don't think they'll answer that, but I'll give you the answer. A kilogram is about 2.2 pounds, 120 newtons between a guy and a girl. Probably would never ask that question again. All right, 10. What is in the same units? Well, weight is newtons and force is newtons. So that was a good one. We never went over an extra help. Hey, by the way, the extra help is posted. That video, if you want to check it out, the volume, the recording's not the greatest, but I think you can figure it out. Oops, let's see if I can let somebody in. Yeah, open queue. Everybody's in, right? Nobody's good. Oh, a lot of people showed up. Terrific. Whoa. Okay. So what didn't we do? I don't think this one's a worth. Let me see did we do gravity? Um, let's see. I want to see if we did gravity. Now this is basically the same as we did before. What didn't we? How about relationships? Nah, that's not going to help you. Conservation of momentum. Of course, you're going to know that remember tomorrow, the total momentum before any interaction equals the total, use the word total momentum after, so you'll get some points for that. Let's see if we did I think we actually, yeah, we did this. But for those, let me do a few for those of you who didn't show up. Um, Everybody asks me, look at this, two carts, 5 and 1, start from rest. You know what that tells me when I see that? Starts from right. You know what it tells me? It tells me that M1 V1 equals M2 V2. So that should trigger right there. They start from rest and they're pushed apart by something. That's what I'm looking for. Starts from rest. Watch how easy this is. You've got the 5 kilogram and it goes 2 meters per second. And you got the 1 kilogram, and usually you don't know one of the four things. So 10 equals 1 times v. V is, oops, not 10 kilogram meters per second because we're looking for the velocity. So this can't be the velocity, nor can this because it's kilogram meters per second. It can only be this one or this one, but it is obviously this one. Okay? So starts from rest, something pushes them apart. Okay? And so what else? I'm trying to find a different one for you. Even though we did this in extra help, I'd like for those of you who weren't there, I'd like to just go over something that'll help. Let's see what could be good for you. They're all starts from rest. I want something different. Let's go.
Mr. Major Capri,
Yeah,
are all the equations we have to know going to be on the reference table?
yeah. They're all on there, except for the one exception, is M1 V1 equals M2 V2. So just memorize that when it starts from rest and something pushes them apart. It's M1 V1 equals M2 V2. I'd love to do a because we know it's going to be on the test. I'd love to do a total momentum before and after question because we know we're going to get that. Let's see if we can find one of those and let's show them all. Let's see if I can find it. Oh,
Wait,
here's one. Go ahead.
the only time that we ever use M1 V1 equals M2 V2, that's only when it says starts from rest. So we
Start from rest and push apart. Start from
okay,
rest,
so,
push
okay.
apart. Yeah, and you're gonna get about three of those because they're very popular in the regions. And so if I know it's popular, so I want to make sure you're gonna get it come June. Let's take a look at this bottom one because you know you're gonna get a problem like this. Uh, so you've got a 2 kilogram mass, M1, 4 meters per second. Um, North, that's a positive thing. 1 kilogram going south. So, what's the total momentum after? Well, they gave you all the stuff about before. How can you find the after? By finding the total momentum before, you're really actually finding the total momentum after. So the 2.0 kg. How fast was it going? Well, that's the north one, positive 4 meters per second plus 1 kg. How fast was it going? Well, this one's going south, so negative 8 meters per second. And that's the total before, which of course is the total after. 8 plus negative 8. Oh, the answer is just 0. See that? So that's when they're going in opposite directions, you've got to make them, opposite velocities. The north, like in math class, is positive, and the south is negative. Let me show you a good one here. You might see something like this. Which one's got the greatest momentum? So what I say to myself, well, I know what momentum is. It's simply m times v. It's on my reference table. Why don't I just find all the m times v's? 9 times 3 is 27. 4 times 4 is 16. Well, that's obviously the biggest momentum. Isn't that easy? So, unit for momentum, that's m times v. So that's the kilograms times the meters per second. How about this one? This is a good one because you'll probably see something like this. 10 newtons F, mass m. So this is what you should do. T. What's the change in momentum? So I go to my reference table. What do I see? I see this. And I see delta P. But when I do put it on my paper, I add one more thing. Don't write on your reference table. Write it right across part one and part two, and you build your own equation. What's that? F, T, oh, delta P. I'll pull that down. Oh, F and T, look at that. I can see that FT equals delta P. What's F? 10. What's T? 8. That's 80. Look at that. Done. Boom. Okay, that's like, what do you got? What do you want and what fits? Let's take a look at this one over here. It's a nice one. Newtons. Um, 5 Newton force when impulse J. Now, how do I know that? I look on the right of my reference table. That's J impulse. The force is acting a period, and all of these are times. So I go to my reference table and I build my own equation. What do we got here? Oh, F and T and J. Oh, look at that. So J equals F times T. F, so the J is 15. The F is 5. Piece of cake, right? That's 3. Any questions, girls? Or things maybe you'd love for me to go over? Or
Wait,
Mr.
why?
Major Capri,
go ahead.
Could we do like the 1, 2, 3 physics, like the impulse?
Yeah, oh, terrific. No problem. No
Wait, why
problem.
did you use like you only use the 10 and the 8? Where'd the 6 go in question 4?
Oh, what a great question. I want you to get used to it. Doesn't happen a lot, but at times you simply don't use something. Don't let it throw you off. It never happened in chemistry, but it happens in physics because you're at the next level. I love that question. I got the T. That you should, and what's the change in momentum? So don't always feel like you got to use it. Uh-oh, I got to plug in.
Wait, so in the change in momentum, if you ever see mass, do you just leave it alone? Or is it
No, that's not the rule. Here's the rule. Let me plug in because I think this thing's getting low. I got to get my plug. Give me a second while it started to. No, that's not the rule. The rule is look what you got. First of all, you focus on what do they want. I bet I got to use something with delta P. Next question is, well, how could I solve? What could I do? Well, let me go through this again with my little pen. Show you my thing. Where did I put my pen? Oh, there it is. Okay. So let me show you my thinking. I say, well, I got to find impulse, and I've got this equation, delta P. And what a great question. Yes. Why didn't you use the M? I realized I can get J with just F and T. I don't even need M. This is just perfect. And if I don't use something, I don't worry about it. So that's a good question. You just find something that fits, that fits, solves. And it was very clear I didn't need the M because I got J equals FT. Now I'm going to do some impulse with the 1, 2, 3 physics. Let's go to 1, 2, 3 physics. Go to St. Mary's. Go to show me the physics. Review. 1, 2, 3 physics is here. We're going to do some impulse. Okay. Type this in. I don't know, most of you know it's Mr. M. Let me in. Okay. And pick a topic and pick mechanics for a long time. Then we're going to pick where are you? Impulse and momentum. Now I want to prepare you so you girls don't freak out. Some of these are really, really hard, so don't freak out. You're not going to get a lot of hard ones, but you want to do plug-in impulse? Whoever just asked me, should we do
Yeah, the plug-in.
plug-in? Okay. All right. So watch the strategy. Ready? Bullet. So I don't even know what I'm going to do. So V. Okay. Brought to rest. Oh, V equals 0. The final impulse. So this is what I'm doing. If I'm taking a test. What is the mass? So I said, okay, I got to use that big equation that I wrote on my test. And this is what it looks like in the reference table. I'm going to add that M delta V. Let's check it out. They talked about impulse. They talked about M. Oh, look at that. J equals M delta V. So that's what I use because that's the fit. So what's the J? 50 equals M, which I don't know. Now, what's the delta V? Technically, the delta V is, that's 500, right? So it's negative 500 technically. But you want to know something? They want to ask for the mass, which is always positive anyway. So J, V. So the delta V is technically, wait a second, yeah, negative 500. So you divide both sides by 500. And that cancels out. This is actually must be a negative. Let's see. J, impulse of J, what is it? Oh, I'm sorry. It's not it goes, oh, it's brought to rest. Yeah, it is. But we don't worry about the sign because it's mass. Hold on, I'm getting something on my phone. That was my sister. I'll call her back. So 50, so cross out the 0. 5 divided by 50 is probably 0.1. Right there is 0.1. And you calculate it, maybe say 1. You could put it in scientific notation. 0.1 is 1 times 10 to the negative 1. Did I go too fast? You want me to go over it again, anybody?
No, that was good. Can we do like
Yeah.
the next few?
Next few, okay. So good. These are good questions, okay. There are not a lot of calculations because it tends to bog students down. I don't put too many because you wouldn't finish the test. So I put a moderate amount, but great questions. Because a lot of kids have trouble with the math. Math. What is the speed? V equals question mark of a M with a momentum P. Your reference table will tell you that. So PMV. P equals M times V. What is the speed? Unknown. The mass is 2 times, whoops, ran out of room. So uh, P is 2 times 10 to the fourth. P equals M, 1 times 10 to the third kg times the V. So you divide both. This is really 1,000. This is 20. You could just do 2 times 10 raised to the power of 4 divided by parentheses 1 times 10 to the third. So you can see that this is 1,000. This is 20,000. You divide both sides by 1,000. Don't you get 20? Which is right there. 2 times 10 to the first.
Wait, what tells you to use that formula? Like, what
Oh,
tells
great. Well, look. VMP.
No,
go
but
to-
like, is there any words? I feel like a lot of them are just.
No, yeah. Speed is V. The kilograms is M. Good question. Kilograms is M, and the word momentum. So PMV. I go to my reference table. There it is.
Wait, when do you use the one that's like M1 plus V1 equals?
Oh, that's when they ask for total momentum. We just did a problem, didn't we? When you see total momentum, you got to do M1 V1 plus M2 V2 if there are two things. If there's, that's how you do it. You have to do the momentum of each, and if they're going in opposite direction, make one positive, maybe the one go to the right positive, and the one go to left negative. Does anybody want me to do a few more of these calculation things? Just to show how I do it?
Yeah.
How do you know what to make negative and what to make like
Oh,
positive?
you think about math class. Here, good question. In math class, you know that the left, it's no surprise. We just follow the convention of math. To the right, we make positive. To the left, make negative. Talk about north, we'll make positive, and south will make negative. Or west, negative, east, positive. So there you go. Maybe we'll do.
Wait, but it won't like you just do what the answer is. Like, if it's positive, it's positive. It's negative, right?
Yeah, once you tally it all up, you'll either get a
Oh.
positive, maybe you'll get 0, or you'll get a positive answer or a negative answer. And if they ask for say magnitude, well then you don't have to even put the negative at all. They just want the number and the unit. Okay. I'll show you a few more. Just watch this, because some of you do have trouble with the math, finding equations. So let's try this one over here. Kilograms, M. Meters per second, V. T, seconds, force. What's the force? Well, mv. So I get my big long equation, J. I get this from the reference table. And I build delta P, and then I add on my sheet, not on the reference table, this. So mv, ft. So I build my equation, ft equals m delta v. I just put everything in. The f is unknown, right? F. The t is known, 0.01 seconds. The m is known, 0.15 kg. The delta v, this thing gets stopped. Now, technically, it's negative 20. That's the change. But that's interesting. Usually they say, what's the magnitude of, very interesting. This is a Regents question. They really should have said, what's the magnitude of the force? But all right, no problem. I'll just
Wait,
multiply.
why is it a negative 20?
Well, it really is a negative change. When you start at 20, you stop a ball, it's changed by negative 20. But on a Regents, if you get a negative answer and they're all positive, just look at the number, not the units. Don't worry about it. But what's so interesting is usually the region says what's the magnitude of the force, and that's really funny that they left that out. But I'm just going to calculate, multiply these two numbers, and divide by this, and I'll get the answer. One of these four will be the answer. Okay, let's do some. You know what I'd love to do for you, because sometimes kids get tripped up. Could we do some gravities? Let's do some gravity relationships. When you do gravity, though, I want, when you look at it tonight, do not. Let me show you what to not look at. So gravity, don't bother doing plugins. Relationships are really good, and knowledge is really good too. So, and not this one here, not two. That is just way too tough. I would never put that on the test. So when a satellite is a distance r, the force of gravity is F. When it's 3r, oh, now you're moving away. So it can't be the same. It can't be stronger. It's one of these two. So I look at my reference table and I say, what's that relationship in gravity? Well, it's got the R. The R is the separation. So you're tripling it. You're tripling this number, but that gets squared and it's on the bottom. So it's 1/9. Right? If it says double, you'll say 1/2, triple 1/9, 4 1/16. And if it says 5 times greater, you'll say 1/25. Okay?
Wait, but what do you plug into that? Like, what do you
Well,
plug into?
this is really about a change and a relationship. It's not really, well, you kind of plug in the change. They said it went from R to 3R. That's a way to say it's tripled. So you plug the change in, well, into your equation, and you say, well, R is 3 times bigger, so that 3 will get squared, and it's on the bottom.
So you just take the number that gives you and square it, and that's pretty much.
Yes, well, squared and inverted. I think you also know, like I said before, if you're getting further away, these two answers are ridiculous, aren't they? It's got to get, first thing you say is gravity's got to get weaker. Come on, you're going further away. Is it 1/3 or 1/9? And you say, oh, wait a second. The distance is squared on the bottom. So any change gets squared. The 3 gets squared, and that's why it's F/9. That's a pretty popular question for the Regents, and I tend to like to put it on. Here's another one that is very similar. It'll reinforce what you're doing. Let's see how's the time going. We're almost done. So I'll do this, and then one more request. So you've got, this is something you saw in class. You've got, let me underline when you do this, A and B. Compared to the magnitude of A, magnitude of the gravitation B. So you compare A and B. Well, A is close and B is far away. So B is far away, so it's weaker, right? It could be this one or this one. Well, it's twice the distance. Oh, that's right. It's twice the distance. And I look at this equation. Oh, twice is 2. 2 squared is 4. 4 on the bottom is 1/4 is great. So I'm going to take one more question as a parting question. Was there anything that maybe you came into this session tonight wondering about, need some clarity? I'll do one more thing. Okay.
Can you go over the different type of momentum equations, like
Yep.
and like all the different types and when to use them?
Okay. So if it's a collision, all collisions, then a collision problem, two things hitting each other, well, then you're going to use, and if there are two of them, you're going to use that. Equals, M1 V1 equals M2 V2 plus M1 V1 prime plus M2 V2 prime. But when are you going to use this equation? Well, this is, when you use it, you look at, what did they give me? Did they talk about impulse? Did they talk about force? Did they talk about time? Or, basically, when they start talking about these things, pull down what you need. If we've talked about again and again, objects starting from rest, as soon as I see that, automatically I do this. Automatically. If I ever did something where the two objects, here are two objects in the beginning, but then they collide and attach. Well, what do they become? they're now not two objects, but they're one object with this mass and that velocity. So this is when they collide and attach afterwards. So they have two things. They hit, they collide and attach, then they become one thing. So what else is there? That covers the moment. So this is for like when they mention any of these things, use this. When they talk about collisions or things pushed apart, you use that. And
Wait, and you divide by it? I feel like I've never seen that before.
well, yeah, you did because we did it in class. Two objects collide and attach, they become one object. And then what would happen is you'll have everything in this equation, but maybe you won't have the second velocity. That's how all these things work. You have everything but one thing, and then you do the math. You might have that this is 2, that's 1, 2 kilograms, 1 kilogram, right? You have a velocity of this and a velocity of that. Maybe you don't know the velocity after. Look in your notes. There's one like that where they collide and attach. Look for collide and attach, and that would be that problem there. All right. Any last question? Okay, girls. Good luck. There aren't a lot of super hard problems, but follow the method that I showed you, okay? You have a great night.
Thank you.
You're
Thank
welcome.
you.
Thank you.
You're
Thank you.
welcome. Let me stop this recording. Let's see. Do we do that? Uh-oh.